Hey everybody, what's good? What's going on? JB here, back with another CyberInsight live stream. We're doing day 12 of TryHackMe's Advent of Cyber. Today's room, we're going to be looking a little bit at malware analysis, be talking about static analysis, dynamic analysis. I think we're doing this on a Windows box, so we'll be looking at some different tools that allow us to take a look at the Windows operating system and see what's going on when we have application that might be a little malicious. So I'm going to dive into this. If you got any questions, throw those in the chat. Make sure you smash the like button, subscribe to the channel, all that other good stuff. And we are going to jump into this. So forensic McBlue to the REVscue. So the malicious document attached to the phishing email was confirmed to have been executed. Aside from the fact that rogue connections were observed, we don't really know what else it was doing. So our in-house expert, Forensic McBlue, confirmed that the malicious document spawned another suspicious binary. Pivoting from that, he dumped it from memory for this task to be further analyzed via malware analysis. So what are we going to be talking about? We're going to learn a little bit about the fundamentals of analyzing malware samples without relying on automated sandbox scanners. So there are tools that you can buy out there that will do a whole bunch of analysis automatically. We're kind of starting from ground zero here. We want to learn some of the basics so that we have an idea of what these automated scanners are doing. We're also going to be talking about learning and understanding the typical malware behavior and its importance in the incident response pipeline. So when it comes to malware behaviors, before we touch the malware sample itself, we're going to talk briefly about some common malware behaviors to have a good perspective on what to expect when we're analyzing it. So a prominent word in cybersecurity malware is software created to harm a computer or even an entire network. Threat actors develop malware to achieve specific goals such as infiltrating a network, getting sensitive data from that network, or disrupting operational services within an environment. If you were to inspect several malware samples in the wild, a typical pattern arises, making analyzing other samples easier with experience. Knowing these common behaviors gives us an idea of what to look for on the defensive side of things. So a few different things: network connections, registry key modifications, and file manipulations. And obviously this is talking about, since we're talking about registry key modifications, we're talking about a Windows box. So with network connections, malware normally tends to establish either external network connection or internal connections. External connections allow command and control type of traffic, so remote access, or to be able, remote access to be able to see what's going on within the box, download other types of staged payloads that are hosted back within a threat actor's infrastructure. Meanwhile, internal connections allow for lateral movement, a technique used to extend access to other hosts or applications within the network. In essence, that's pivoting. When it comes to registry key modifications, malware typically uses registry keys to establish persistence, a technique used by threat actors to discreetly maintain long-term access to a system despite disruptions. So a good example of this is registry run keys, which allow binaries to be automatically executed whenever a user logs onto a machine or whenever it boots up. And normally these types of things will coincide with a different type of mechanism than what was used to initially get a foothold in the environment. Lots of times we have blue teams and folks that are looking for different types of intrusions, and they might notice something and they're able to go and mitigate that and clean that up. A good adversary is going to have some fallback plans and make some additional configurations so that if that initial access is detected and remediated, that they have another way to be able to get into the box that was compromised. The last one is file manipulation. So malware tends to download. One of the common reasons to establish network connections is because of the fact that it tends to download something or create new files needed for its successful execution. So given this, we can expect the possible behaviors of malware during the investigation when we look at the mystery gift binary that we identified in the previous task. So dangers of analyzing malware sample. So obviously it's bad, it's going to do bad things. You don't want to necessarily go and open this up on a box that has connectivity to other boxes in your environment or has internet access. So a lot of times we're going to see this would be done in some type of sandbox. So with this, here are some helpful tips when handling live malware. Always assume that the malware samples will infect your device. Hence, executing it is not always the first and only step in analyzing it. only run malware samples in a controlled environment, so as I mentioned, kind of like a sandbox, to prevent potential compromise of unwanted assets. And it's always recommended to have your sandbox, as I mentioned, which allows you to have worry-free execution of malware samples. A good sandbox to be able to do stuff in, I think it might be loaded up in the VM that we're using today, but Flare VM has a whole bunch of analysis tools within it. It's free. I think it was originally, I don't remember who put that together originally. I think it was Mandiant. So you can go, you can search for that, and it's a great sandbox to be able to test different types of malware in. You just want to really make sure that it doesn't have any type of network connectivity, especially if you're running it as a VM. You don't want it to actually have connectivity to your host and the rest of your network that you're running it on. So, as I mentioned, a sandbox is a controlled test environment that mimics a legitimate end-user working environment. It gives analysts a safe environment to execute malware samples and learn the behavior. Lastly, having a ready sandbox prevents analysts from running malware samples on their workstations. No bueno. Which is highly dangerous and impractical for the possibility of unwanted impact. In a typical setup, a sandbox also provides automated analysis at the disposal of the security analyst to determine if a binary from a set of malware samples requires further manual investigation. For this task, we're going to use the Flare VM instance. Just go ahead and click the Start button up here. The VM will serve as our sandbox. However, do not expect that this machine to provide an automated analysis, since we will assist Forensic McBlue in conducting a manual analysis. So here we're going to talk a little bit about the difference between static and dynamic analysis. So we already kind of understand the safety concerns with handling malware and where we want to do that within a sandbox. But there's two main types of analysis that we can do. The static analysis, which is a way of analyzing a malware sample without actually running it, without executing it. So this method mainly focuses on profiling the binary with the readable information that is readily available there, such as properties, program flow, strings. And we're going to see what that means here in a second. Given the limitation of not executing it, sometimes this method gives insufficient information, which is why we're going to have to resort to dynamic analysis. However, there are certain things that we might be able to pull out of that while looking at the strings, which, when coupled with the dynamic analysis, ends up leading to a larger picture. Meanwhile, for dynamic analysis, we focus on understanding how the malware works by actually executing it within a safe environment. So by doing this, we're going to see what the malware does, what it interacts with, what it tries to create, what it tries to connect to, and understanding that, then we'll be able to have a better idea of what it's doing and how to protect against it. So starting off with the static analysis, there's a malware sample folder on the desktop of the machine. And I'm going to apologize if this VM craps out. I've noticed I tried to spin this up a little bit earlier and it would disconnect every once in a while. So we'll just reconnect if that happens, but apologies if that does happen. So we have this malware sample folder here. We can pop this open and we see the mystery gift binary that we identified in the previous task. So there's a few different tools that we're going to be using: the Detect It Easy and Kappa. So Detect It Easy, otherwise known as DIE. We're going to use that to look at a few different things with that. This tool provides information about the file, such as the architecture, significant headers, if a packer is used. And a packer is really just like common technique used by folks that create malware to compress it and obfuscate it and sometimes encrypt it. So that way it's not necessarily as easy to see what it is that it's doing. So we can go ahead and open this up with DIE first. And we're just going to right click and Detect It Easy right here. And when we open this up, we see a few different things. We see the file type PE64. So we know that the architecture is going to be 64-bit versus 32-bit. We can see that it has detected that there was a packer, a UPX. And we could also go and look at the strings that might be visible here. Now, this might not necessarily give us a whole bunch of great data right off the bat. And all a string is a set of characters that we would be able to see when this is kind of scanning the binary. We might end up seeing some data that might be useful. Sometimes you can pick out maybe a command or URLs or things like that. We also could search. So this is looking, I think this is the character limit that it's starting with. So if we wanted to look for stuff that was a little bit longer, let's say if we wanted to go 20, we could do that. And you see that that kind of shortened the list, but there's an awful lot of stuff in here, and it's kind of hard to scroll through here to find stuff. And also with the fact that it's packed at the moment, we might not be seeing everything that we want to see. So it's good to know this is here, that we can do this. We also, you can run this through the command line. So there's like, you could just run like the strings command if you wanted to. Or you can use this GUI like this. Oh no, and we can see that the network connection has dropped on this. We'll see if it comes back up. We'll give it a second. So let's see what they say here. Upon opening, we'll immediately discover the binary's architecture and the executable packer used. So as I mentioned, it was using UPX and it was 64-bit. Packing malware is a common technique. Well, we already kind of talked about why they do that, to compress, obfuscate, or encrypt the binary. So they have us kind of looking through here. They talk about some of the things that we could end up finding with strings. As I mentioned, IP addresses, URLs, other types of file names. That's it. Reconnect on this. And we're back in. So the next one we were going to do was Kappa. And we're going to use that with the CLI. And Kappa is used to detect capabilities within an executable file. So cute name, Kappa, capabilities. Maybe may it be for the installation of service, invocation network connections, registry modifications, and such. So to start using Kappa, we're just going to use the CLI. And we're going to move into the directory where the malware sample is, and then just run Kappa and mystery gift, the name of the binary itself. So let's go cd, and that was desktop /malware sample ls to see what we got in here. We got mystery gift. So we're going to go Kappa, mystery gift. All right, it's kind of doing its thing. Now, because of the fact that this is packed, it's probably not going to be able to show us too much. But it should tell us that it's packed. And that's exactly right. So this sample appears to be packed. Packed samples have often been obfuscated to hide their logic. Kappa cannot handle this obfuscation well. So what can we do about that? Well, when we used Detect It Easy, we did see that the binary was packed with UPX. So we can use UPX to actually unpack it, I guess, or to take the packer off of the binary file, and then we can use Kappa after that to reanalyze. So to unpack it, it's just UPX -D and then the name of the binary. So let's go UPX -D mystery gift. Okay. If we go ls, then we see that there. Now we also see here this mystery gift.viv. This is kind of like an artifact that ends up being created whenever we use Kappa. And if I were to run this again, it actually would read this instead of the file, and we would get the same error. So what we want to do is actually remove that file so it's not there, and it will completely run again. So we're just going to use this command here, this delete, and then rerun the command. Okay, and then we can go Kappa, and we just double check to make sure that's not there. Yep, okay. Kappa mystery gift. And this obviously should take a little bit longer than it did last time when it spit back that error message about the fact that it was packed and it couldn't really analyze it. Okay, so we got a lot more information out of here, which is cool. So we got some hashes that we can go and use. So we could take this and we could go to like VirusTotal or something like that, look that up. It's cool. It's got this table here talking about attack tactics. So if you remember from day one, we were talking about different types of frameworks, and the MITRE attack framework, which helps you kind of identify the different tactics that an adversary will use. Well, here it's pointing out what it's doing is obfuscating files. It's trying to discover files and directories. It does some execution, and then it does some persistence with boot or login auto start execution. So registry run keys and a startup folder. So this might be foreshadowing to some stuff that we'll see when we do our dynamic analysis. Some other things that might be kind of cool to point out within here. It's compiled with NIM. It encodes data with base 64. Let's see, anything up? Reference startup folder for persistence. Yeah, that's probably the cool things in this at the moment. So let's go see what else they got here. Okay, so that's kind of what they wanted us to do before getting into dynamic malware analysis. So before we do that, let's go see what questions they're going to have at the bottom of this. And since we just did the static portion, maybe we can answer some of these before diving into the dynamic stuff. So what is the architecture of the malware sample, 32-bit or 64-bit? Well, so if you remember, when we were looking at die, which might be closed out at this point, it showed us that it was a 64-bit. So we can just go 64-bit. What is the packer used in the malware sample? And remember, this is what we use to actually unpack it. So that was that, it was the UPX. Let's see, right up here. And again, that was in the die as well. UPX, not UPS, no, UPX. There we go. What is a compiler used to build a malware sample? We noticed that when we were running Kappa. It kind of threw this out here, compiled with NIM. And then how many MITRE attack techniques have been discovered? How many MITRE attack techniques have been discovered attributed to the discovery tactic? Discovery tactic and file directory discovery and system information discovery, so 2. All right. I think that about covers the static portion. Let's go up and look at the dynamic portion. So deep dive into dynamic malware analysis. So as we observed, we cannot execute the binary after double clicking on it. Well, we didn't observe that because we didn't try it, but we can't because of the fact that it's not a .exe, it's not executable. So before renaming and executing the binary, let's prepare the tool we need for analyzing its behavior. So we're going to use Process Monitor, or also known as ProcMon. This is a great tool. I think, I'm trying to remember if I did a video on ProcMon before. I'm pretty sure I did in some of the Blue Team videos. All of the sysinternals tool sets, there's a whole bunch of tools that kind of fall under that. ProcMon is one of those. This is great from a cybersecurity perspective, Blue Team perspective. It's great from a engineering perspective, operations perspective, just for troubleshooting different types of issues. So if you haven't used it before and you work with Windows boxes, you definitely want to go and check it out. So it's a Windows tool that shows real-time registry, file system, and process thread activity. It also shows you the network connections that those are making. So there's a lot of really cool data that you can get in real time as things are working behind the scenes on your Windows box. So we're going to open up Procmon. We're going to set up a filter on this to only monitor the process name mysterygift.exe. Now, we haven't actually created this yet. Down here, we're going to move mysterygift and rename it as mysterygift.exe so that it can execute. But let's go and set that up with Procmon. So we want to make sure that we choose this here, not architecture. We're looking for process name. And we're going to go mysterygift.exe, add, and that's going to be included while the rest of these are excluded. And we can go apply, and we can go OK. Now, we can come back over here, and we're going to go move mysterygift to mysterygift.exe. And we see that it now is renamed to that. We can go, and now we can double click on this. I think that's what they're going to want us to do. Let's see what that is. Yeah, okay. So now we move to pop the malware. We can just double click it, and then we're going to go in Procmon, and we're going to look and see what we have. Now we have that rule set up so that it's going to include this. We're probably going to see a whole bunch of data coming in, and we're going to have to filter that. But the main things that we're going to be looking at is registry activity, network activity, file system activity, process thread, and I think that's kind of the main ones that we're looking at. And we can see these kind of thumbnails here that we're going to be clicking through. So let's go ahead and do this. Kick this off. And we can see that we have a bunch of events coming in. And we can move this over and get into this. So we see all this stuff for Mystery Gift. We see all these registry things coming in. Opening a key, querying a key, closing a key. All sorts of stuff. We're going to dig through this in a second, but I just want to show you all the different types of data that we have coming in. Now, the important thing with this, as you move through here, if you click on both, it's going to show all of it. So if you want to just see the specific activities, then you unclick and just go one at a time. So this here is the file system activity. So this is creating files, viewing files, editing files, closing files, all that type of stuff. This one is really interesting. This is a network connectivity. So we can see right off the bat that this is going to a website, bestfestivalcompany.thm. So we'll keep an eye on this to see what type of stuff we might see continuing to come in through here. And we can see some process stuff. And okay, so let's go back to the beginning here and see what we can do starting with a registry. Let's see what they want us to do. Okay, registry modification. So we want to determine any significant registry modifications are executed by the binary, which is one of the expected behaviors that we talked about when we kick this off. So to do this, we're going to show all the registry activity, and then we're going to do some exclusions. So what we want to do is remove opening a key, querying a key, querying a value, and closing a key. So really what we're interested in looking at here is creations and modifications, not necessarily viewing, opening, and closing. So we can go and to remove these, just right click on any of these different things that match the operation we want to exclude. So we're going to go exclude registry open key, exclude registry query value. Again, we want creations and modifications. Close key, we can get rid of that too. Query key, we can get rid of that. And now we have create key and set value. So we have some stuff here. Looks like TCP/IP parameters. But the interesting one down here is setting this value. And this is in the current control set, services, BAM, state. Let's open this up. These are user settings. They're setting this data here. So interesting to note that. So as I mentioned, we can see both the create key and set value. This key is related to a persistence technique called Registry run key modification. It's commonly used by malware developers to install a backdoor. So now we're going to take a look at the file modifications. And same type of thing here. We're looking for if the malware is executing file creations, and that's indicative of malware dropping prerequisite files for successful execution. So again, we're going to filter out things that we don't necessarily care about because there's so much coming through there. And so we're really focusing on file writes. So creating files, creating file mapping, querying, closing, reading, we're not necessarily as interested with this at the moment. So we're going to declick this. It's still going to be there. We can come back and it's still going to be set the way that we filtered it. So don't worry about that. But we're going to come over here and we're going to do the same thing. We're going to exclude a whole bunch of stuff to kind of narrow down the scope of what we're looking for. So we're going to exclude create file, exclude create file mapping, querying, query name, let's see if we ended up let's see. Options. I'm just trying to see if we ended up, if that's happened yet or not. I didn't see any write file activity come in yet. Hopefully I didn't hopefully I didn't make it so that that wasn't let's see if we can go load filter, reset filter. Okay. Let's try this again. Go filter. We'll just do that again, put that in there, mystery. Gift.exe, process name, add, apply, okay. Let's see if that's still going to be there. Okay, so we were looking for the file write. I just want to make sure. I didn't see anything pop up in here yet. We can run the malware again. There we go. I think that was write file is what we were looking for. Yep, okay. So running it again, now we can get rid of these other ones, create file mapping. We queries, close file, query. All right, so we see some write files here. We see it going to temp to test.jpg, and then we also see it going to this wishes.bat. So that looks like the malware is creating those two files. And we could dig into this more. We could actually go and drill down in to see if the files are there. Sometimes the files are there and they persist. Sometimes the files are there to do something and then the malware cleans up after itself. So it doesn't necessarily mean that that file is still there. So what do they say? You may observe two files are written under user admin directory. Yes, the first file is in the user's temp directory, which is commonly used by malware to drop another file for its disposal. And the other file is in the startup directory, which is used for persistence via startup. And so that might also have something to do with that registry key, maybe, for boot up. So maybe it will run this whenever the user logs in or whenever the machine boots up. Okay. Now let's see what the network connections. So lastly, we're going to look at the network connections. We kind of already did that right off the bat when we went over here and saw these. So we see it going to bestfestivalcompany.thm. Also see it going to VirusTotal, which is interesting. So I don't know if maybe it's checking to see if there's any samples of itself up on VirusTotal, and then maybe if something gets flagged, then it will delete itself or modify something or request a new payload be downloaded so that it can hide itself from people looking for things that are already up on VirusTotal. But kind of interesting that it's doing a lookup to VirusTotal. So we did those things. Let's see what they talk about. Conclusion. So we covered some things: the key behaviors of malware, aid in having an overview of what to expect, why we need to use a sandbox. We did some static analysis. We did some dynamic analysis with Procmon. And now let's take a look at the rest of these questions. So what is the registry key abused by the malware? Well, so if we go back, and we'll just add these excludes again. And we're going to get to the set value, I believe. Is going to be HKCU software Microsoft Windows current version run. Let's go that. So it's going to be HKCU software Microsoft, I believe. No, software Microsoft, yep. Software. I wish I could copy and paste back and forth between these Windows VMs, but I haven't found a way to do that. Windows current version run. Windows current version run. Let's see if this... That is it. Cool. What is the value written on the registry key based on the previous question? So let's see this here. We can see that this is the path. So it's the start. So this is definitely the program startup stuff. Yep. Okay, so it's C:\users administrator. Administrator. App data roaming. app data you should be able to copy and paste this box. For the attack machines, definitely. On this I tried before and wasn't having any luck. I don't know, it could also be my browser. I'm using Safari for this, and so I know that sometimes I've seen it work fine with Chrome, but Safari not so much. Microsoft, Windows, Start menu. Program start. Well, let's see. Where did I screw it up? Users, administrator, app data, roaming, Microsoft. Windows, start menu, programs, start. I messed up on the slash. I think at the end, maybe? No. I'm not sure. I don't know. I don't think there's a space there. There isn't there. Roaming administrator. I must have it jacked up somewhere. Pretty sure that's the answer. We'll come back to that. What are the names of two files created by the malware under the admin directory? So remember that was there was a JPEG there that we saw. So it was a test.jpg, and then it was a wishes.bat. .bat. Okay. What are the two domains wherein malware has initiated a network connection? So that was a best festival and then virus total. bestfestivalcompany.thm. And virustotal.com. And it says, go back to strings inside the malware sample. What is the complete URL used to download the file? So like when we're looking at this here, it has the domain we're going to, but not the full path of what we're going to on the website. So let's see if we can do this. Detect it. It's easy. Strings. Let's see if this works. Can I go HTTP? Yep. Okay. So I can search for HTTP here, and we see HTTP bestfestivalcompany.thm/favicon.ico. So let's go with that. HTTP bestfestivalcompany.thm favicon.ico. All right. Oh, by the way, so this intro to malware analysis, I actually have a room that I already did on that video if you want to go check that out. It's a really cool room too. And this guy here, I am very positive that that is correct. We'll just take one more minute looking at that, and if not, we can just wrap up the video. And I'll just figure it out on my own so that I can make sure that I get credit for it, but pretty sure that is the case. We were looking at what is the written value of the registry based on the previous question. Oh, maybe, let's see, let's go back to this, right? Yes. Let's pop this open one more time. Users, it's backslash administrator, yes. App data, roaming, Microsoft. I probably spelled like Microsoft wrong. Windows. Oh, maybe that's why. We didn't. Yeah, that was a dumb move. Okay, programs, startup, which is startup. See, that's why you always get a double check. Startup wishes.bat. Bam, that's it. All right. Cool. I appreciate everybody dropping in. Yeah, leave any comments or questions or whatever. Share the videos with your friends, all that good stuff. So I'll catch you tomorrow with, what is it, day 13. So, all right, take care. Have a good evening. Bye.